So today we'll work on Newton's method of approximation. Okay, so given a function f, a number c such that f of c equal to 0 is called a 0 of f. I think you already know from your high school or pre-calculus. For example, if f of x is x squared minus 4x plus 3, then f of 3 equal to 0 and f of 1 equal to 0. If you just substitute those values there, that's what you're going to get. So that both x equal to 3 and x equals to 1 are called the zeros of f. In another word, if you solve x squared minus 3x minus x squared minus 4x plus 3 equal to 0, if you solve it, you're going to get the, the x value will be and 1. That's what it means, okay? 0 means the solution of the equation, or zeros of the function solution for that equations, okay? And in many areas of pure and applied mathematics, we sometimes required in finding solution to an equation of the form f of x equal to 0. Okay, the zeros of linear, quadratic, and other simple functions can be found with the method of algebra, which you already know from your pre-calculus or from your high school. You found the zeros of function of simple linear or quadratic functions, hundreds of those, I believe, in your high school and pre-calculus. But sometimes if the function is given like this, let's say if you want to solve this this equation, it's not that easy. Your algebra method is not going to help you, or even if it helps, it's going to be really complicated. Or sometimes if they give you an equation like, let's say 4 ln x plus ex squared, okay, plus square root x plus 1 over x plus, something like that. Let's say x raised to power 7 equal to 0. Then solving this equation using high school algebra, can you think of how difficult it would be? Or it's kind of impossible, right? So, and today's we learn a technique that's called Newton's method, which allow us to solve any kind of equation, okay? We will be able to find the approximate value no matter what kind of equations we are given. And here is the formula for Newton's method. xn plus 1 equals xn minus xn over f prime of xn. So here are the learning objectives. By the end of this unit, you will be able to describe the step of Newton's method, approximate the zeros or roots of given function using Newton's method, and recognize when Newton's method does not work. All right. So first of all, let us develop this formula. Let us talk about what exactly the Newton's method is. Okay. Look at this graph. When we say roots or zeros or solution, what we are talking about is this value right here, where the graph crosses the x-axis. This is called roots or zeros or solution to the equation, okay? So we are interested to find this value, this x value right here. And let us suppose that this is my function f of x. Okay, this line, the curve is the graph of the function f of x. Now, the idea here is that we first choose one value on the function, one point on the function randomly. Okay, generally close to the root, but for simplicity, I choose this point. All right. And let us suppose that this point is x naught, and I denote that by x naught, y naught, or you can say x naught or f of x naught. This is my point. This is a random point that I choose. So using this as a, as a basis point, try to find the approximate value of this here. That's the goal. Now, let me ask you one thing. What is the equation of a tangent line passing through that point? Okay. Equation of tangent through x naught and f of x naught. Okay, this one. X1, I mean x, you know the formula, y minus y naught equals m times x minus x naught, right? That's the formula. Or you can write y minus y1 m times x minus x1. It's the same thing. Okay, so if this is the formula that we already know. So let us substitute the value. Y minus y naught. Y naught is f of x naught equals m. That is the slope of the tangent line. Okay, slope of tangent line at this point is, we know that that's the derivative, slope of the tangent line. But because this derivative of this function at the point x naught y naught will be f prime of x naught. That is my slope. And x minus. Is there any question so far, guys? That's the equation of the tangent line, right? Now tell me, what is the coordinate of this point x1? It will be x1 and 0, right? Because it is on the x-axis, so that will be 0. Y will be 0. Okay, so since the line passed through, the tangent passes through the point x1 and 0, we can substitute the value. Okay, so we can substitute the value of this here. So y means, so this means my x equals x1 and y equals 0. That's what it means, right? That is x equal to x1 and y equal to 0. So let us substitute those values. Y means 0 minus f of x naught equals f prime of x naught, and x is x1 minus x naught. Now let us do a little bit of algebra here. So x1 minus x naught, f prime of x1, sorry, this equals minus f of x naught over f prime of x naught. Everyone is okay with that? It's a little high school algebra. If I divide both sides by f prime of x naught, that's what I'm gonna get. Okay, simple algebra gives me this. Now if I want to find x1, then that's gonna be x naught. Let me take this x naught to the other side. X naught minus f of x naught over f prime of x naught. Okay, now look at the pattern. Similarly, we can find, now look at the pattern. When there is x1, there is x naught, x0 minus f of x0 over f prime of x0. So if I continue this pattern, if I look at that pattern, if I ask you, what is my x2? Can somebody tell me what will be x2 there? X sub 2? Look at the pattern and tell me what it will be. x1 minus f of x1 over f prime of x1. Everybody agree on that?
Yes.
If it is 1, there is 0, 0, 0. If it is 2, there should be 1, 1, 1. In the same way, similarly, x3 3 will be x2 minus f of x2 over f prime of x2, right? If I continue that way, tell me x plus, x n plus 1 will be, what that will be?
xn minus fxn divide f prime n.
Thank you. This is the formula, okay? This is what the Newton, you know who is Newton, right? So Newton came up with this formula long time ago when um, and then this method is really, really helpful for so many different kind of functions or equations which cannot be solved easily by using the high school algebra. So I want you to remember this formula, okay? X of n plus 1 equals xn minus f of xn over f prime of xn. Okay, with this formula, now we are ready to solve few example. But warning, I just want to remind you that Newton's method may not work if there are points of inflection, local maxima or minima around the point that you randomly choose. So whenever you want to choose some random value, random root, then try not to choose the value at the point of inflection or at the local minimum or maximum point, okay, or around that point. Anyway, we'll talk about that later. Here is example 1. Is starting with x not equal to 6, find the fourth approximation, x sub 4 to the root of the equation x cubed minus 467 equal to 0. So let us find approximate value, fourth root. What does that fourth root means? Well, what is given here is given f of x equals x cubed minus 467. Okay, I consider this as my function. And I want you to find the derivative, which is 3x squared. Okay, so start with this x not equal to 6. So what is given is also given that x not equal to 6. I will say let x not equal to 6. It is given. Okay, then our first fourth approximation, find the fourth approximation. So let us find x1 according to the formula. Let me just write the formula. Okay, this is my first root, or maybe you can write given first root or first 0 is this. Now let us find the second root or second solution or second 0 represented by x1, and we know the formula. X1 is x naught minus f of x naught over f prime of x naught. So this is the formula. Let us substitute the value here. X naught means 6 minus f of 6 over f prime of 6. Guys, I want you to find out what is f of, okay, f of x is x cubed minus 467. And what is f of 6? Which means 6 cubed minus 467. And f of x, f prime of x is 3x squared. So f prime of 6 will be 3 times 6 squared. So I want you to find out what are those values, okay? And let me know. Am I right? So this value is negative 251 and this value is 108. Is that correct, guys? You got the same thing? Okay. All right. So that's what I got. And second root. And we need to find fourth root. So let us find third root. Third root, which is represented by x sub 2. And the formula is x1 minus f of x1 over f prime of x1. So that means 8 point, x1 is 8.32407. Generally 4-digit, okay, right, at least 4-digit after decimal. Minus f of 8.32407 over f prime of 8.32407. So I want your help, what that will be. I use my calculator directly. Okay, let me see what I got. Okay, I'm going to use my calculator. So the first one will remain the same, 32407 minus, if I plug in this 8.32407 in my function f of x, so my calculator is giving me 109.7768. But I want to verify this answer with you guys. And when I plug in this value 8.32407 in my derivative function, and my calculator is giving me 207.8706 approximately. So now let me use calculator again, and the total, okay, so this, and my calculator tells me that the calculation of these numbers turn out to be 7.79597. But I want you to verify whether that my calculation is right or wrong. Sometimes I may punch the wrong button, so I want you to actually, make sure that this is the correct one. Now let us find fourth root, which is given by x3, and the formula is, let me write fourth root a little bit here. x3, the formula is x2 minus f of x2 over f prime of x2. And so f of x2, x2 is 7.79597 minus, let me plug in this value in my function. When I plug in this value 7.79597 in the function here, over f prime of 7.79597. Let me see what my calculator tells me. Okay, the value will be okay, so when I plug in this 7.79597 in the function f of x equals that value, then my calculator is giving me And when I plug in this same x value in my derivative function f prime of x, my calculator is giving me okay, but guys, I want you to verify this answer, okay? And so the final answer here is going to be 7.75858. To be on the safe side, you can write approximate sign here like this. Okay, so if you know how to do this example one, the concept is pretty much same. So you will be able to solve all the other problem, but let's try a few more questions just for fun. Here is example two. Consider the equation. Okay, so the given function here is 2 ln x plus x minus 3. I consider this as my function. And the interval given here is 1 and 4. Use Newton's method to find a solution on the given interval to the nearest hundredth. Nearest hundredth. Pay attention to that. Now, in the earlier example, example 1, we were given the starting root, starting value. Okay, we were given that value and we just wanted to find the fourth root. But here we are not given any starting point. You need to choose that. As a matter of fact, you can choose any point in between 1 and 4. Any number between 1 and 4, including 1 and 4, okay? You can choose 1, you can choose 1.5, 2, 3.5, 3.9, 4, you know, like 2.152670, whatever you like. You can choose that as your first root. But for simplicity, I choose this 1 as my first root, okay? To make life easy, I'll choose x naught to be. But in order to, if there is any root, then what we want to do first is we want to check whether there is any root between 1 and 4 or not. We are not sure whether there is any root, because sometimes what happens is that we use this Newton's method and we keep on working on that, and at the end of the day we realize that, oh, there is no root, there is no answer between 1 and 4. So that's just wastage of time. So what we do is that we want to make sure that there is a root, there is an answer for this equation within that interval. Okay, we want to make sure that first, and then we start working. If you know that there is no root, if there is no solution on that, then there is no use of starting working using the Newton's method. Okay, so that's what we're gonna do. How do we do that? Do you know intermediate value theorem?
I think we can plug in F1 and F4 if the sign we change. It means the function have to cross axis.
Yes, Q, excellent. That's what we are trying to do. Yeah, that is called intermediate value theorem. Okay, just Q just said intermediate value theorem, IVT. From now onwards, in short, I call it IVT. So you learn this theorem in your high school, in your pre-calculus. What this theorem tells us is that, suppose here is one point, okay, let's say A, and this point, your Y value is positive, meaning f of x is positive, because this is above the x-axis. Okay, because this point is above the x-axis, above x-axis, Y value is positive. So this point is y is positive. In another word, f of x is positive. Let me consider one point below the x-axis, anywhere below x-axis. Let's say here. This is point B. And this point is your y value negative, which means f of x is negative. All right. Now, intermediate value theorem tells us that if you want to join this 2 point, if you draw a curve, doesn't matter how you draw, it could be this, it could be, you can go all the way there, or you can go all the way there. No matter how you try to go, if the function is continuous, then it must cross the x-axis. And the crossing point, we call it solution, we call it roots, we call it 0. Okay, so it must cross. So that's the idea. If one value is positive, f value is positive, and another f value is negative, then there must be a root. Okay, meaning the function must cross the x-axis. That is called intermediate value theorem. Yeah, thank you, Q. Now let's look at whether there is a root or not. Okay, so since f of 1, let us substitute that 1 there, so that you'll get 2 ln 1 plus 1 minus 3. How much is this? This is 0, so you'll get 2, which is positive. I mean negative 2 you get, sorry. You get negative 2, which is negative. And let us put this 4, okay, the endpoint of the interval 4 in the equation. You're going to get 2 ln 4 plus 1 minus 3. Definitely this is positive. I think this will be approximately 3 point something. Okay, 3 point, let me see what my calculator tells me. Okay, my calculator gives me that it is 3.7726, which is positive. Okay, so according to the, therefore one f value is negative, another f value is positive, so there is a solution or root to the equation on the interval 1 and 4 by intermediate value theorem. Okay, all right, so we now know that there is a root. Now let us find the root now. Okay, so for simplicity, suppose my first first choice of the root is x naught is 1. Like I said, you can choose 1, you can choose 1.5, any number in between 1 and 4 doesn't matter, but for simplicity, I choose this x naught equal to 1. Okay, our first guess. This is our first guess. Now let's find the second guess or second root. Second root or second guess, which is given by x1. The formula is, we already know, x1 is x naught minus f of x naught over f prime of x naught. And I'll do this for you, and then you complete the other one for me. So this gives me x1 minus f of 1 over f prime of 1 equals 1 minus f of 1 is, if I plug in the value 1 there, I'm going to get negative 2 over f prime of 1 is, oh, I need to find the derivative here. So the derivative is 2 over x plus 1. Okay, so if I plug in this value 1 there, so I'll get 2 over 1 plus, so it is basically 3. Okay, when I substitute the value x equal 1 in the derivative function, I'm going to get 3. So if you solve it, you're going to get 1.6667. Okay, four decimal, minimum 4 decimal places. Okay, four digit after decimal, please. Now third root, which is x2. So that's going to give me x2. I mean, the formula is x2, formula is x1 minus f of x1 over f prime of x1. We know this formula, and let us substitute the value. So that's going to give me 1.6667 minus f of 1.6667 over f prime of 1.6667. And 1.6667 minus, let me plug in this value in my calculator in the function. So my calculator is giving me, okay, let me see. My calculator is giving me, this is to be negative 0.3116. And when I plug in this value in my derivative function, my calculator is giving me 2.2, but I want to verify that with you guys. And so let me calculate all of these, and my calculator is giving me 1.8083. Okay. Now, the question tells us to find the answer nearest to 100th. What it means is you switch that to nearest to 100. So that's going to give me 1.67. If you do the nearest to 100th, that's the value. Now here, nearest to 100, this is the value, 1.80. I mean 81. So this 1.67 and 1.81, they are different. So we need to continue. We need to continue until when we round up to 100th. Until we get the same number, we need to keep on, finding the values. That's what the meaning of this nearest 100th means, okay? So let us calculate fourth root as well. Fourth root, which is x3, the formula is x2 minus f prime of x2 over f prime of f of x2, f of x2 over f prime of x2, which gives me x2 is 1.8083 minus f of 1.8083 over f prime of 1.8083, which gives me 1.8083 minus, let me plug in this value in that function, and my calculator is giving me negative 0.0069 over 2.106. That's what my calculator is giving me. And when I calculate this, again using calculator, it gives me 1.8116. Now let me round up to nearest to 100th. When I round it up nearest to 100th, I'm gonna get 1.81. Okay guys, good news. So we got 1.81 here and 1.81 here. Now you can stop and relax. That will be your answer. Nearest to 100th, we got the exact same value. If we, okay, does that make sense to everyone? That's how we, when they give us this nearest to 100 or 1000, that's what we're gonna look at. So our answer is, so x value is 1.81 nearest to 100th. That's it. Okay, so example 4, use Newton's method to approximate the following to the nearest thousandth. Nearest thousand, so keep that in mind. If you're allowed to use this, to use your calculator and find the value of this number, it's pretty easy, but here we are told to use the Newton's method. Okay, so let us use Newton's method and then find the approximate value. All right. First of all, remember what we need is we need to know what is the function and what is the interval. Look at this. What we should know in order to use the Newton's method is we should know the function and we should know the interval. But here the function is not given and the interval is also not given. So how do we use the Newton's method? Well, we use our common sense. Okay, so the common sense is, let us suppose that x equals cube root 11, then using high school algebra, can I write x cube equals 11 now? Is, cubing both sides, that's what you're gonna get. And this gives me x cube minus 11 equal to 0. It is just like what we did earlier. So our function is, so let our function is x cube minus 11. Now let us figure out what is the the interval. Okay, we need to figure out the interval. How do we do that? Okay, to find the interval, we use a simple common sense again. Okay, so our function is x cubed minus 11. Now let us use our common sense. If I plug in f of 1, what do I get? 1 minus 11, which is negative 10, which is less than 0. If I plug in 2 for x, I'm gonna get 2 cubed minus 11, which is minus 3, which is also negative. If I plug in 3, I'm gonna get 3 cubed minus 11, which is 27 minus 11, which is 16. That means positive. Remember, one value is positive and another value is positive, means the answer, the root, must lies between 2 and 3. That's how we figure out. Okay, so since f of 2 is negative and f of 3 is positive, there must be a solution to the question or to the equation on the interval 2 and 3. Okay guys, even though there is no function, no interval, but we are able to figure out what is the function and what is the interval. Now we are ready to use the Newton's method. So for simplicity, let us consider x naught to be maybe 2. Okay, you can choose any value between 2 and 3, but I'm choosing x not equal to 2 for simplicity. Now let us calculate our second value, x1, second root. The formula is x naught minus f of x naught over f prime of x naught. Okay, your second root, x1, is, by substituting those values, you got 2.25, and this root will be x1 minus f of x1 over f prime of x1. I want you to try this on your own without looking, but if you need help, then of course you can look at it, but I think you will be able to do it by yourself. So this is 2.25 over f prime of 2.25, which gives me 2.25. And if I plug in this value in my calculator, well, I leave it to you, whatever you get. And then my calculator is giving me approximately 2.22428, or okay, at least four digit after decimal at least. So I'm doing 5 to be a little bit more precise, but yeah, at least 4 digit after decimal. I suggest that. And now let us calculate. Okay, when I round it up nearest to 100, so this guy is actually 2.25, and when it rounded up, so it is again 2.224. So they are not equal. Nearest to 1000 means 3 digit after decimal must be exactly same. Until we get the exact same number after 3 digit after decimal, we'll keep on continuing using the formula. So let us calculate x third root here, which gives me x2 minus f of x2 over f prime of x2. That's going to give me 2.22428 minus f of 2.22428 over f prime of 2.22428 equals, and let me plug in this value in my calculator, and my calculator is giving me, which is approximately, let me see, okay, so this is what I got. And if I approximate this to nearest to thousands, what do I get? Let me see, 2.224. Okay guys, good news. So we got 2.224 and 2.224 here. So that means we are done. So nearest to thousands. Okay, this is 10th, 100th, and 1000th. Nearest to thousands, so we got that value. So your answer is x is 2.224. This is the answer, which is nearest to thousandth. Okay guys, this is all about Newton's method, and then we'll take a break. Okay, so we already learned how to apply Newton's method to solve given equations, right? To find the roots or zeros of a function. Now the question is there any situation where Newton's method fails? So we want to discuss about that, okay? Does it always works? Is there any situation, any cases where Newton's method actually fails? Let's look at this. Example 3. Consider the function f of x equals x cubed minus 2x plus 2 on the interval -2 and -1. Let x naught equal to 0. so that the sequence x1, x2, all, and then these sequence fails to approach the root of f. Okay, now we'll show this. Here, f of x is given to be x cubed minus 2x plus 2. You can find the derivative, which is 3x squared minus 2. Okay, so given x not equal to 0, and let us calculate x1, and the formula is the first root is, the second root x sub 1 is given by x naught minus f of. Can you try this? What do you get? Your x2 is equal to 0. This is your first root, second root, third root, fourth root, fifth root, okay, notice that we found, we calculated, we started with our first root as 0, x not equal to 0. We calculated second root x1, which is 1, third root x2, which is 0, fourth root x3, which is 1, and then 0, 1, 0, 1. You see, this just oscillates between 0 and 1, right? So that means it's not going to give us any value in between this. Remember, we are looking for an answer between -2 and -1. But notice that what we got is, we don't get, 1, 0, both of them are not within that interval. So you're not getting the roots within that interval. Okay? Here, the numbers continue to alternate between 0 and 1, and closer to the roots of f, never to the root of f or the 0 of f, which is on the interval -2 and -1. So the root is there. So the reason is because, let's draw the graph. What could be the reason why it is behaving so. Let us look at very quickly. Okay. If I draw the graph of this function, let me draw the graph here. Graph of f of x. So the function is f of x equals x cubed minus 2x plus 2. So if I draw the graph, when x equal to 0, when x equal to 0, it is 2. So this is 1 and 2, let's say. So this will cross from here. When y equal to 0, solving this gives me approximately somewhere here, approximately, 1.8, 1.9 negative, somewhere there. And then the critical number is going to be around 1. So if I draw the graph, it may not be the accurate graph, but the graph looks like this. This is 2, and this is 1, 2. Okay, guys, I draw the approximate graph. Notice that this 2 is actually the inflection point. You can prove that x equal 2 is inflection point by taking the second derivative. Okay, first derivative is 3x squared minus 2, and then the second derivative is 6x. So the inflection point is actually second derivative equal to 0. So that's going to give me 6x equal to 0, x equal to 0. What? When x equal to 0, what is your y? When x equal to 0, your y value, or f of 0 is going to be 2. So 0 and 2 is inflection point. So this is your inflection point. Okay. Now, remember the warning that I said earlier at the beginning of the class, that if you choose your first guess to be an inflection point, or the point where the maxima and minima is, then you may not get the this Newton methods may not work. Okay, that's what I said earlier at the beginning of the class, and that's what is happening, because when x equal to 0, basically this is the inflection point, and you don't want to choose that value. So let me write this down here. Note that x equal to 0 is the inflection point. So to avoid this kind of situation, avoid this situation, choose an initial guess x naught, that is your initial guess x naught, first root, okay, initial guess x naught closer to the actual root, okay, closer to the actual root. So for example, suppose your x naught is 1.5, it is somewhere, you know, close to 1.5. You can consider -2 as well if you like. So close to x naught equal to -1.5. I think this will give you the correct answer. Okay, now let's complete that just for fun. Your x naught is, let's say, -1.5. You can choose -2 if you like. You can choose -1.2 if you like, but close to that root where the, you know, function cross the x-axis. So now your x1 will be, according to that formula, it is x naught minus f of x naught over f prime of x naught. And so you can get x naught is -1.5 minus f of -1.5 over f prime of -1.5, which gives me, let me put this in my calculator, and this gives me approximately 'approximately this much I get. And it makes sense. This is, you know, this is close to -1.8, okay, the actual root. But if you want to be more, if you want to find, you know, even better approximation, you can calculate x2 and you can calculate x3. Okay, that's what you can avoid the situations when you have this, you know, 1 0 1 0 just alternate and we are going nowhere. We're not going to get the, you know, value within that given interval. So that's one technique you can use to avoid that kind of situation.